Hello everyone, welcome back to Let's Unbound. In this video, we are solving FRQ 2 from the AP Calculus PC 2025 exam. It's all about a polar curve. You will learn many must-know concepts like rate of change, area under the curve, and like area between the curves and motion problems. So we will go through everything step by step. So it's super clear and it will be easy to follow. Make sure your calculator is in radian mode as this is a calculator part. And let's get started. Curve C is defined by the polar equation. R of theta is 2 sine power 2 theta. For theta lies between 0 to pi. From 0 to pi, curve C and the semicircle are equal to half for theta to pi are shown in the xy plane. Okay, so this is x and the y plane, but actually it's a polar curve. I hope you got the point. Now, find the rate of change of R with respect to theta. First rate of change, and we will see more clear in next step. So for next B is find the area of the region that lies inside the curve C but outside the graph. So area between polar curves is second part. Now C part is they have given dx by d theta for the curve C. And for particular interval like 0 to pi by 2, we need to find the value of theta that corresponds to the point on curve C that is farthest from y-axis. So we need to find a point, like a value of theta, where your point is very far from the y-axis. Justify your answer. Then this is a kind of question. And D is particle travels along curve C, have d theta by dt 15 for all times t. Find the rate at which particle distance from the origin changes with respect to time t. And when the particle is at the point where theta is 1 by 3, show the setup for your calculation. Okay, so let's go one by one. First part A, find the rate of change of R with respect to theta. So we need to find dr by d theta. R is directly given to us. For the curve C, R is what? R of theta is 2 sine square theta. Next is rate of change of R means dr by d theta, which is how will you differentiate? 2 times. So 2 will stay as it is. Don't put 2 become 0 as it a constant. It is a multiplication. Then times sine square theta will be, how will you apply power rule? Because it's sine theta is a function, squaring is a function, right? So this thing, we will first break down the power. So 2, how will you work on this? So you will multiply this power front, put the same as it is, then reduce one power, same thing. So 2 sine theta times, what is our another function? Sine is another base function. The differentiation of that you should put here. Sine theta differentiation is cos theta. Don't confuse with sine here. So dr by d theta is 4 sine theta cos theta. I need to find the rate of change of R with respect to theta at this moment when theta is 1.3. So dr by d theta at theta equal to 1.3, just we're going to plug in, it's simple after this, 4 sine 1.3 cos 1.3. That's it. Next, we need a calculator help. I'm going to share Desmos now. So we will solve it using Desmos. Okay. So what I need to find? 4 times sine 1.3 and cos 1.3. Use the parenthesis. And one more thing, your calculator should be in radian mode. Cos 1.3. And this is our answer, 1.03100. So when you got a lot of decimal, round it to 3 decimal places. So it will be 1.031, right? So that's our final answer. Here we move to, right. So at this moment, it's approximately 1.031. That's complete problem A. And we are moving to part B. Okay, find the area. Yeah. Find the area of the region that lies inside the curve C but outside the graph of the polar equation. Don't confuse. This is polar curve in xy plane. Okay, so they define from 0 to pi only for theta. But for xy, it can be negative, right? So don't think, okay, well, should we find only this area because it's 0 to pi? No, not like that. Okay. Right. So area that lies inside the curve C. So this is inside the curve C. But outside the semicircle, R equal to 1 by 2, outside this, I don't want this. So I'm deleting it. So which will be, this is the perfect region we need to work on. So this comes under, when I shade the region, This is the area we need to find it. And this is nothing but area between two curves. Correct? So area between two polar curves formula. Directly go for it. We have everything. And let's solve. Area between polar curves. So area is half or upper square, sorry, integral. Integral, the limits, we need to find it, or outer curve, like or upper curve minus lower curve between two curves, right? So maybe let me give up. Or upper curve squared it minus or inner curve squared it. Then this is a complete integral. Use this bracket and d theta. Okay. So r upper curve is c, that is r equal to 2 sine square theta. When you square this, 4 sine power 4 theta, right? So I will write it half integral. I will work on the limits, but now I'm filling this. 4 sine power 4 theta minus r inner is this 1 by 2. 1 by 2 square, 1 by 4 d theta. Now what is my limit? These are the limits, but they are x and y values. Okay, so we can't do that, but I mean, I need the interval in terms of theta, not in terms of x. So it's the intersection of the two curves. That is your theta, that is the limits. So to find the intersection of the limits, I'm again going to use Desmos now. Okay, here we go. So what are the two curves we are working on? Yeah, it is actually r is equal to half and okay, 0 to pi only we are working. Just type pi and r is equal to 2 times sine square theta. These are the two curves we are working. Right? Can you see the exact image we got? 0 to pi only. So, right? And where they are intersecting, I need to find it. But again, I will get x and y values, but I need theta, right? So in the settings, you can go for like a x-axis, y-axis is one more. Another one is this radian, like polar curve. We can use it. So now this will give me the intersection points. Okay. So here they intersect. This is the intersection point, and you can see it's 5 pi by 6. Right? And here there is an intersection point, it is 5 by 6. Got it? So that's it. I got my intersection points, which is 5 by 6 and 5 pi by 6. So now we are moving into whiteboard. Let's solve this. So it's 5 by 6 to 5 pi by 6. And again, I need calculator help. Same expression, exactly this one. I will put it in the Desmos and solve for it. So let's go. Again to the Desmos. Okay, what I need to find here is the expression. Let me put it here. So half. I think this things we don't want now. So half integral pi by 6, pi for pi by 6, and here 5 and then pi by 6, pi by 6. Use the parenthesis properly so that you won't get any error. Okay, what is my integrand? I hope you remember this 4 sine power 4 theta. Theta, I can just type theta minus 1/4 and then d theta. Okay, it shows some error. Yeah, one thing in Desmos, you can't use, you can use still power 2 for trigonometric function. Sine cube means you should write it sine power 2 theta, sine theta. Like this way you have to use. So that's why it shows error. So sine power 4 theta, I will use sine square theta, sine square theta. Times again sine square theta. So this one we need to do. And how so that you will get the input will be accepted. Okay. So 4 sine power half integral pi by 6 to 5 pi by 6. Brackets are properly given. Okay, let me close these. Okay, let me make it like this. So 2 times sine square theta whole square. We delete all this. Minus 1 by 4. Yeah, now it accepts. Right? So the curve, entire curve form. So yeah, you can do these changes like this. And we got 2.0067. And taking to 3 decimal places, it will be 2.067 approximately. Right? And we are moving to whiteboard now. And this is the final answer. So it's approximately 2.067 square units you can give as its area. Hope this is clear. Moving to part C. It can be shown that dx by d theta is 4 sine theta cos square theta minus 2 sine cube theta for curve C. For theta between pi from 0 to 2, pi by 2, find the value of theta that corresponds to the point on the curve C that is farthest from the y-axis. Actually, we are connecting theta and xy plane, right? So if it's farthest from y-axis means x have to be maximum, either this side or this side. Correct? So we will be using, so I need to maximize x, not just x, maximizing modulus of x. So that's the main thing. Maximize modulus of x. How will you maximize something? You differentiate and set it to 0. That's the same. They clearly provide us dx by d theta equal to 0 and solve for those theta values. And they clearly give that 4 sine theta cos square theta minus 2 sine cube theta equals 0. Correct? Now I need to solve them. Yeah, I can use Desmos again for solving this. Yeah, here again, we should know some techniques, how to get the answer without error in Desmos. Here we go. Let me try to give directly what is the equation and set it to 0. Okay, my equation is 4 times sine theta cos square theta times cos squared and then theta minus 2 times sine cube theta. You can't use sine cube, so sine square theta times sine theta. It shows an error, correct? So let me treat it in xy form. That will be much better. So 2 part equal to 0, correct? So this is equal to 0. This is what we got. So what I'm going to do is 4 sine x cos square x is one part, y equal to, then another y equal to 2 sine square x into sine x. And I will solve at the intersections. Okay. It's very simple. Instead theta, I'm using r and theta, I'm using x and y. It's not like x and y will be, here x will be an angle. Okay. So that will give us without any errors. 4 times sine x times cos square x. Here. Let's use the parentheses to avoid it. Again. 4 sine x cos square x. See, we got the curve. Next one is 2 sines y is equal to 2 times sine squared of, sine squared x times sine x. Sine cube will not be accepted. See, sine x. And where they intersect, that is my answer. So 0 and 0.955. So I got two answers down. Now let's finalize our conclusion part here. So from this, from solving it graphically, I got theta is equal to, don't put x is equal to, theta is equal to 0 or theta is approximately equal to, it shows like, did I show? Yeah, and it shows like 0.95532. Okay, so justify your answer. Like our solving thing is itself justification. Now, how can I say, okay, this is the one thing, this is the algebraic procedure we know to maximize this. Now, you can prove this, you can justify this by taking the candidate test. Like you can just plug in theta and x of theta. X have to be greater, correct? That is our aim. So when it's 0, when it's 0.95532 and pi by 2. Don't forget to apply the candidate test here. What is x of theta? Okay, what is x actually? It's our cos theta, correct? X is or cos theta. What is my or? Or is 2 sine square theta cos theta. So I'm going to plug in this. Again, I need calculator help here to solve further. So let's go to Desmos. So now I'm just naming y and not in theta terms. So y is equal to 2 sine square x cos square x. 2 times sine squared x times cos x. Okay. And I need to test the values at 0, then 9.5. So when x is equal to 0, I need to test at x is equal to 0 0.9, wait, what? 0 0.955. 0 0.955 approximately. And ending point x is equal to pi by 2. Okay. So let's check the values, the blue, green, and this. When x is equal to 0, this is also 0. This intersection is 0 0.769. This intersection is 0. So I'm going to list this and finalize my answer where it will be farthest from y-axis. 0, 0, this is something 0 0.769. Right. So that's it. This is the highest one. And the point, let's justify our answer. The point on curve C is farthest. Let me write it. The point on C farthest from y-axis. This is what we are finding, right? From y-axis, when it will occurs when your theta is this much, 0 0.955 approximately. This is the final justification, final answer. Okay. Right. So why we pick that? There it is maximum. Rate of change of x with respect to theta is maximum. That's why we picked that. And also we did candidate test. It's not maximum anywhere at the end points also. So we go with critical point. Hope it is clear, and we are moving into part D. A particle travels along curve C so that d theta by dt equal to 50 for all times t. Find the rate at which the particle's distance from the origin changes with respect to time t when the particle is at the point where theta is 1 by 3. Okay, what had been asked here? Right, so particles moves with d theta by dt's rate of change of theta with respect to time t. We need to find rate of change of the curve or with respect to t at the given theta. Okay, so what we need to do here? And also they said distance from the origin, right? So distance from the origin means it means dr by dt. dr by dt. They didn't directly give you, but distance particle is moving in or. So dr by dt. I should write it in terms of this. This is all I know. You can write it dr by d theta times d theta, chain rule. Correct? I know this. So dr by dt is 15 times dr by d theta. All I want to know is dr by dt at this point. So theta equal to 1.3. Here also you should put theta equal to 1.3. This we already calculated. Very first dr by d theta when theta is 1.3. The very first part of this problem here, right? It's 1.031. So we can directly use it. So here we go. So it's 15 times 1.031. Basic multiplication in calculators. I'm not doing this, sharing a different screen, right? Okay, here we go. So this is approximately, you will get 15.465. Go for 3 decimal places approximation. That's it. So we did the rate of change of particles distance from the origin when the particle is at the point theta is 1.3 is this. is the rate of change. Right. That's the wrap for FRQ2 from the AP Calculus BC. Okay. So if you find this video helpful, you can show your love and support by subscribing and giving a like and giving a comment, or you can share your doubts and feedbacks also in comment section. So next question, we will be posting that very soon. Until that, you can keep learning. If you want to join the student community of Let's Unbound, the WhatsApp group link will be given in the description, right? So that you will get updates and you will get a chance to connect with the other learners like you. So see you in the next one. Keep learning and keep practicing.